Okay, so the next problem in the lead code we are solving is keys and rooms. Okay, so basically, what is being given here is, let's say that, let me just open the paint. Okay, we have got a too many rooms. Okay, like let's say that it's a list of lists. Okay, and you can consider this as a each room. Okay, this as a zeroth room, one room, second room, and third room. Okay, and what is that mean is, so zeroth room is always open. Okay, it's left open. Okay, and it has a key for room number one. Okay, that's what it means. So we can pick the key and we can go to room one. Okay, and we can go inside a room number one, and there is a key for some other room. Okay, we can take it and we can go to the second room, and okay, there is one more key, we can pick it and open the room number three. Okay, similarly there is nothing, that's fine. Okay, so basically this is the problem about. Okay, so at the end what we'll need to find out is, are we able to traverse, like I mean go to all the rooms that is present. So currently we have four rooms, we should be able to visit the all the four rooms. We can label our room names as 0 1 2 3. Okay, and coming to this, right, let that example be there. Okay, so what does this mean? So room number is 0, room number is 1, 2 and 3. Okay, when you go to room 0, you will get an access to 1 and 3. So either you can go to room number 1 now and open it, or you can go to room number 3 directly. Okay, you got an access. So if you go to room number 1, right, you got an again access to the room number 3 or room number 0 or room number 1 itself. Like I mean the key to that room itself is there. Okay, and so actually 1 and 3, right, we can just draw a graph. So we can just draw a path, actually not a graph. No, let's not go there yet. So 3 and 0 and it will be 1, right? So if it just draw it nicely, right, let's say that we have a separate rooms. Okay, let's say 0 is here and one room number 1 is here. Okay, and when we say, when we are at 0, we have an access to go to the 1 and 3. Okay, so for now let's write 3 here. Okay, using 1 I can go to either room number 1 or I can go to room number 3. I have a path, right, I have a key to go to the room. And similarly when we took the room number, this is the room number 1, correct, this is the room number, their index is starting from 0. Okay, so when you go to the 1, you can actually go to room number 3, right, when you go to room number 3, and also you can also go to the room number 0, right, you can go to room number 0, and finally you can go to the key to that itself is present. Okay, this is one thing. So next, let's say that if we go to here, right, 2, there is some. Okay, let's first go to the room number 3, we'll come back here. So when you go to the room number 3, there is an key for room number 0. Okay, you can just say this. Okay, and for room number 2 has a key for itself. So there is a room number 2 separately. Okay, we have total 4 number, right, the key to itself is present. Okay, so basically what's happening here is, we are getting some keys and going to some path, and from there we are going to some other path. It's like, it's we are getting a route there, correct? Either when we talk about a route, it's either a tree or a, like I mean this can be a graph, correct? So a tree would be like, I mean ideally, like it has a specific connection, right, left, right, all those things. That doesn't satisfy here basically. So this satisfies the graph data structure. Okay, so we are going to go with a graph data structure approach. Okay, so because will be able to traverse from another, and it's actually clearly shows that it's a directed graph, correct? Zero is, we can, from 0 we can go to 1, but we are not sure from 1 we can go to 0 or not. But once we analyze itself, we'll get to know that if it is possible or not, right? So now coming to the solution, right? What we have to do here? Okay, now we got to know it's a graph, right? So to come to the solution, we need to identify. We need to just what are they asking? We need to identify if we are able to go and unlock all the rooms or not. Okay, so if you are able to traverse all the nodes, right? Like this will be the how many number of rooms are there? That will be the length of the list. Okay, that will be the four numbers. If you are able to traverse all of these four rooms, it means that we are able to unlock all of them, right? That is a simple actually. So using this path and everything, if we are able to traverse it, for this we can either go with a breadth first search or depth first search. Like we'll search for, like I mean we'll traverse it, and we'll maintain a visited nodes list. Okay, and if the visited nodes list is equal to the length of this room, right, it means that we have visited all the rooms, right? So now check the code, right? So we either you can use a DFS also. DFS also works. BFS also works. So we just want to make sure that we traverse it and we maintain the visited nodes list, and it's a DFS, okay. And we will at the end we'll see if we are visited all the nodes actually. And as we know that we cannot keep the duplicate, right? We don't keep the duplicate in the visited nodes. So we are sure, and we can compare it directly. If the length of visited nodes is equal to length of rooms, it means that we have visited all of the rooms, or else it is not. So in the case of this, right, second condition, what will happen, there is no way that we can go to 2, correct? We can go to 0 to 1, 1 to 3. So if you just apply the BFS, we'll add this 0 to the queue, okay. And then once we pop up, once we pop out, we will be adding 1 and 3 to the queue, correct? And similarly, like 1 and 3 will we cannot like, I mean, there is no any other nodes. So we are good here actually. 1 and 3 wise we are good. And the 2, we are not able to reach it there. So at the end, when you do the comparison, we have visited nodes, node will only have 3 nodes. So at the end we'll get a result as a false, okay. And actually this can be treated as a one to simplify, right? Like, I mean, which can be using that uh, yeah, sorry for the disturbance. So for the ease of use, what we can do is we can actually represent this in a dictionary format. We can access it like a 0 is mapped to adjacent list. Sorry, 1 comma 3. Okay, and 1 is mapped to 301. Wherever from, like, I mean, from where it is linked to. 2 it is linked to 2. Like, I mean, we can represent it like that, and we can solve it. Either we can directly access the index. It is based on the index. Yeah, that is it. Thanks.